This is part 2 of T6 Basic Formation. In this lesson, we talk about basic formation concepts to include heading, crossing, and aspect angles, turn circles, pursuit curves, line of sight, plane of motion, and close formation station keeping. Heading crossing angle is the angular difference between the longitudinal axes of two aircraft. Heading crossing angle is also synonymous with the term angle off. Aspect is expressed in degrees off the tail of the reference aircraft, commonly expressed in multiples of 10. Aspect angle is not a clock position and is independent of aircraft heading. At 6 o'clock to the reference aircraft, the aspect is 0. At the 3 and 9 o'clock positions, number 2 is at 1's 9 aspect. This is also known as the 3-9 line. Number 2 should normally remain aft of number 1's 3-9 line during maneuvering. Line of sight refers to a straight line from your eyes to the other aircraft. Forward line of sight means the other aircraft is moving forward on your canopy towards the front of your aircraft. No line of sight means the other aircraft is stationary in your canopy. And aft line of sight means the other aircraft is moving aft on your canopy towards the tail of your aircraft. Line of sight rate is the speed at which forward or aft line of sight is occurring and is expressed as slow, moderate, or rapid. While moving through an air mass, aircraft have a plane of motion along the aircraft's flight path. The plane of motion is where the nose of the aircraft is pointing relative to the horizon. In a level turn, the aircraft's plane of motion is parallel to the ground, regardless of bank angle. In a loop, the plane of motion is perpendicular to the ground. As an aircraft maneuvers in a turn, the flight path describes an arc, referred to as a turn circle or turn radius. Turn radius is a function of bank angle, wing loading, also known as g-force, and airspeed. Turn radius increases as airspeed increases, or bank angle or g-loading decreases. Here, the blue line represents the flight path of an aircraft traveling at 180 knots indicated. The red line is the flight path of an aircraft traveling at 200 knots. When both aircraft begin a 30-degree bank turn, the red plane has a larger turn radius since it is traveling through the air mass faster. Likewise, when two aircraft are flying at the same airspeed and maintaining altitude in a turn, if they have different bank angles and therefore a dissimilar amount of wing loading, the two aircraft will have different turn radiuses. Here, the blue flight path represents an aircraft flying 200 knots true airspeed and maintaining altitude at 45 degrees of bank, while the red aircraft is also flying at 200 knots but maintaining altitude at 30 degrees of bank. Pursuit curves are used by number 2 for rejoining and position keeping. There are 3 types of pursuits: pure, lead, and leg, and these can be flown in the vertical and horizontal plane. For lead pursuit, number 2 aims the aircraft nose in front of number 1's flight path. With enough lead pursuit, aspect angle and closure will increase, and heading crossing angle will decrease. Here are 6 videos of pursuit in the vertical and horizontal planes of motion. One of the foundational skills required in formation flight is being able to maintain close formation from another aircraft for the purposes of executing formation wing takeoffs, flying in the visual traffic pattern, and maintaining visual of number 1 in IMC. Close formation is a skill that requires a lot of practice and a clear understanding of elevator, aileron, and power usage to maintain stack, line, and spacing in straight and level and turning flight. Wing work is done in basic formation for pilots to practice close formation station keeping while number 1 is executing turns. There are 3 levels of wing work practice based on number 2's proficiency. While leading wing work, use smooth, roll, and pull and attempt to keep 2 in between you and the sun so they aren't blinded by the sun. If either aircraft appears likely to get below 120 knots indicated while maneuvering, knock-it-off procedures must be followed. As number 1, avoid being excessively nose high with minimal bank angle in order to not get too slow. We'll now talk about fingertip stack, line, and spacing visual references. For fingertip, the stack for number 2 is slightly below 1. Stack reference is number 1's exhaust stack on their wing. For line, in fingertip we fly 30 degrees aft of number 1's 3-9 line, also known as 60 aspect angle or 6 aspect. From the front cockpit viewpoint, 6 aspect is maintained by putting the exhaust stack in between number 1's aft position light and the vertical portion of the pitot tube. In some of the pictures and videos in this series, you'll notice the exhaust stack is in between the pitot tube and the fuel vent. This is the rear cockpit visual reference for line. T6 fingertip is flown at 10 feet wingtip spacing. On the 6 aspect line, this is seen as the horizontal stab leading edge directly in line with the rudder hinge. Stack, line, and spacing must be corrected in that order. If out of position, fix stack first, then fix the line, then spacing. There are a number of reasons for this. One reason is if stacked too high, the wing will block the rear cockpit pilot's view of the other aircraft. Additionally, if you're stacked too high, you won't be able to see the pitot tube for the line reference. If not on the 6 aspect line, you won't be able to use the horizontal stab reference to judge 10 feet wingtip spacing. During wing work, number 1 will use a combination of smooth changes in pitch, bank, and wing loading to provide a stable platform with consistent, predictable roll rates and no sudden changes in backstick pressure. Number 2's objective is to maintain or constantly correct back to the fingertip position. To maintain position in close formation, number 2 must make proper power and flight control movements using small, smooth, deliberate inputs. As number 2, trim the elevator while maneuvering and avoid the tendency to focus or stare at any single visual reference. To maintain in proper position, changes in bank, backstick pressure, and power must be blended as necessary into one simultaneous action. Here is some general advice while you are flying in fingertip as number 2. Tip number 1, your bank angle should closely match number 1's, typically within a degree or 2. If your bank angle as number 2 does not closely match 1's, quickly you will lose both your line and spacing. Think of number 1 as your attitude indicator. The bank angle and roll rate of both aircraft must be nearly identical or you will fall out of position. Tip number 2, your control stick movements as number 2 should be very similar to how you'd be flying it as number 1. Large, abrupt, or ratchety control stick movements by either aircraft will cause number 2 to be out of position. As number 2, think about how 1 is moving their control stick. If done correctly, whether straight and level or while executing climbing or descending turns, the stick movements should not be felt by the IP shadowing the movements. For both aircraft, the goal is to, in essence, freeze the control stick. Rather than moving the stick, really you should be smoothly increasing or decreasing the amount of pressure applied left, right, forward, or aft on the stick. Some IPs describe this method of control stick movement as stirring the pot. What some pilots find helpful to accomplish this is by pinning their right elbow to their side and using just their fingertips to move the stick. What you don't want to do is white knuckle death grip the stick. Tip number 3. While maneuvering in wing work as number 2, use continuous, small power changes to stay in position. During wing work, number 1's power should be set and ideally not changed. Number 1's PCL is usually set to between 50 and 60% torque. Number 2, on the other hand, must make nearly constant small power changes to stay in position. Like with the control stick, do not death grip the PCL. One technique you can try as 2 is pin your left hand against the wall and just use your fingertips to move the PCL. Anticipating power changes and engine spool-up time in the T6 is one of the harder skills to learn in formation, which is why power control is an individually graded item on formation flights. In wing work, it is important to avoid large power changes. Rarely is idle or max torque an appropriate PCL position. Tip number 4. When out of position, avoid pilot-induced oscillations by not making corrections too rapidly. A rapidly executed correction typically leads to overcorrecting. If you are stacked 2 feet low, for example, stabilize the aircraft in that position before slowly moving up to correct the stack. So often in the early learning stages of formation, 2 feet low then leads to being 2 or more feet high on stack because the correction was either rushed or too large. These are just a few general tips and common techniques IPs teach. With experience, you'll find what works for you. We'll now talk about specifics on how to maintain and correct position during wing work. Maintaining fingertip position varies slightly between straight and level and during a turn. One thing to keep in mind when discussing wing work is there is a primary way to correct position and a secondary way, and sometimes both are used at the same time. In that sense, wing work can be compared to landing the T6. If your airspeed is slow on final, for example, adding power is the primary correction, but then forward control stick pressure is required to prevent a climb due to the increase in velocity. In the landing example, power is primary for airspeed, but elevator is secondary because moving the control stick forward would also increase airspeed. This action may create an undesirable change in aim point and glide path, however. Shortly in this lesson, we'll talk about power and control stick movements in wing work. Just like with landings, it is important to remember in close formation, when a power change is made, a control stick change is often also required to counter the first change. Conversely, when a control stick movement is made in wing work, a power change is often required. As the pilot, it comes down to deciding what input makes most sense to correct your position or energy state. For that reason, formation is more of an art than a science. We'll start the fingertip and wing work discussion with maintaining and correcting stack. Stack is primarily controlled with elevator movement. If stacked low, increase backstick pressure on the control stick to climb. A small amount of power may also be required. If stacked high, release a little control stick pressure to descend. A small power reduction may also be required. Maintaining line and spacing is a little more complicated for several reasons. First of all, the position corrections for straight and level are not the same as when number 1's bank angle is changing. Secondly, aspect and spacing is maintained by either aileron, torque, or a combination of the two. Starting with line in straight and level flight, power is the primary control used to move forward or aft. As seen in this animation, increasing torque while maintaining altitude accelerates the aircraft, which moves number 2 forward to 6 aspect. Reducing power will cause number 2 to move aft. If aspect is too low, you could also use the ailerons to change your heading. This would technically also get you to the 6 aspect line, but would mess up your spacing in the process. Therefore, to correct line while straight and level, power is the primary input and ailerons are secondary. During straight and level flight, spacing is primarily controlled with ailerons. Turning away from number 1 will create spacing. If power is not added, aspect will also decrease. Keep in mind that when correcting spacing while straight and level, number 2 travels a further distance than 1, so 2 will need to increase torque to prevent falling aft. To move from 6 aspect route to fingertip, roll towards number 1 and add power. Power is used to maintain the aspect, while ailerons create the heading crossing angle required to fix spacing. In summary, for straight and level fingertip position keeping and corrections, the primary controls needed for stack, line, and spacing are pitch, power, and roll, respectively. Straight and level fingertip position keeping is relatively straightforward. Turning while on fingertip, on the other hand, is a bit more complicated. Starting with line, if you roll towards lead and do not adjust power, aspect decreases and range between the aircraft decreases. If you roll away, aspect and range increase. Therefore, in a turn, aileron is the primary input for aspect and power is secondary. That said, power is primary for aspect when 10-foot wingtip spacing already exists, but aspect is too low or too high. If at this point you are confused on how to correct aspect in a turn, that's understandable. In reality, ailerons or power may be required depending on whether spacing is correct or not. To understand this concept, it helps to think about turns using the analogy of two people running line abreast around a racetrack. On the straightaway portion, both people run the same speed to stay side by side. If the person on the inside of the turn stays at the same speed during the curve, the person on the outside of the turn has to run faster to remain line abreast. With that in mind, when 2 is aft in a turn but spacing is good, number 2 will need to increase power to catch up to 1. Number 2 must also adjust bank angle slightly to keep their turn radius constant so that wingtip spacing remains at 10 feet. In this video, spacing is good, but number 2 is low aspect, so power is increased to move forward to 6 aspect, and a slight roll away from number 1 is done to prevent turn radius from increasing, thereby maintaining 10-foot wingtip spacing. As seen here, number 2 gets too far forward and pushes 1's 3-9 line. A roll towards number 1 puts 2 back on 6 aspect. For wingtip spacing in a turn, power is primary and ailerons are secondary. As seen here, when in position and power is pulled, range increases and aspect decreases slightly. As discussed with turn radiuses earlier, adding power increases airspeed if bank and altitude remain unchanged. When velocity increases, but bank angle remains the same, the aircraft turn radius increases. This concept will be discussed again in part 3 when turning rejoins are covered. As a sneak preview to that discussion, just know that power controls closure rate and spacing primarily, and ailerons are used to maintain aspect. That completes this lesson on basic formation concepts. In part 3, we'll look at individual formation maneuvers.